Are there any questions about that? All right. So I'm going to go back into the code here. So we are setting our working directory in this particular case. So now I have fixed that code, so it's going to work. I'm going to put below this check result WD. Check it, it worked. So I already showed you how to upload our data. So we're going to run just one of these, opioid.data frame. It's now up here in, we call it our global environment. You can create other, this is the default environment. It's where it's going to store your files within R. You can create multiple environments you can think of it similar to folders, and store things on different environments. I usually don't use that. So your global environment in almost every case is going to work just fine. I am going to comment this out because we do not want factor variables. I've already shown you what this does. Just in general, tend to run all of the code. So I would run all of this if I wanted to use the mean function. The reason why you have to load everything up here in order to run this. So I'm just going to run that. So now I'm going to find the mean. So this opioid data frame, let's take a look over here. One of the variables within it or columns is prescribing rate. So within opioid.data frame, the prescribing rate, we want to see the average prescribing rate or the mean prescribing rate. So in order to do that, as I said, you would use this $ to separate the opioid.data frame and the prescribing rate. So this is going to refer to this column. So if I run this, it's going to tell me that the prescribing rate, the mean prescribing rate is 79.4 bottles of pills per 100 people. So that's an average across every county, or this would be every state in the United States, actually. So it would be, if you open this, the average of all of these numbers. So one thing to keep in mind when you're using any basic statistical function in R. So the mean function, if you have missing values or values that are not filled in, I'm going to show you what that means. So if I go into opioid.data frame, I'm going to sort by the overdose rate. If I go down to the bottom, I'm seeing NA values. That means missing, or that the data does not exist in your data frame. Reason that some of these do not exist in the particular data set that I was using, these were not available. So it's because in general, often these older years for certain states were not reported. So the source in here, CDC, and these don't exist in the CDC database. Often in this case, I don't think it is this case in general. It'll be because there weren't enough, say, overdoses in the area that you're looking at, and the means were not stable. In this case, I just think that these states in these older years never reported that data to the CDC. So if you have missing data, say I tried to, in general, I like to show what I mean in my code. So say I ran without this na.rm equals true. That means remove na value when you're calculating the mean. I'm going to get rid of that. You'll see that what shows up here is an NA. If you ever see that, you know that there is missing data in this rate. So I'm going to say what happens when data is missing and you run mean. So down here, so this is going to say na.remove equals true. Now, if I run this, it's going to give me a value. So across all states and all years, the mean overdose rate was 6.8. So that's how you would run that. I'm showing this to demonstrate how to refer to a variable within a data frame. Are there any questions about this? All right. So that gives you a little bit of a tutorial on how to use variables. If I scroll down, a lot of you aren't going to know what a correlation is. But I want to, in general, I just want to demonstrate. Go ahead. We can't hear you. There's a lot of feedback for some reason. Okay, never mind. Maybe there wasn't a question. So I'm just doing this. If you want to know what correlation is and you don't already know, take my statistics class. I'm separating the programming side from the statistics side. But I wanted to show you how a function works, a more complex one. So the correlation basically looks at the relationship between the prescribing rate and the overdose rate. So this core test is going to show us that. And I just want to show you, and you don't have to quite understand the syntax here, but I want to demonstrate what a function looks like. So that opioid data frame, we have our prescribing rate in here. And then, so this is the first argument in our data set. So if you want to find a correlation, this is how you would do it. So this would be the second argument. So I'm, in this case, core test, going to look at the relationship between this variable and this variable. And in this case, also, you need that na.rm equals true just to run, because this has missing data. Say I didn't know how to run this. I'm going to look here. It's going to show, in this case, X and Y. You'll see that down here, it'll have and show you different alternatives for the data. So look at this alternative. If you come down here, it says the default is two-sided. It is, I believe, two-sided. If it has an equal sign and shows you different values here, that means it will run. You don't have to specify it usually in those cases. So you see there's no equal sign on X or Y. That means these have to be specified in your function for it to run. So in this case, our first value is this, the prescribing rate. So X is prescribing rate and Y is the overdose rate. So, and then you're seeing that na.rm, you would see down here, say if you didn't know that existed. If you went down here, it would tell you that you had to specify NAs. So that's how you would use this function. So I'm going to just show you what it would look like. In this case, the correlation is very small. So the closer it is to 0, the less of a relationship you're seeing. The reason it's really small in this case is because all the years are included in this data and all of the states are going to be included. I imagine if you would subset it to just 2017 data, this would show a much higher correlation. So it's saying there's no relationship here. And that's just, and if you want to learn more about correlation, take my my statistics class, but I wanted to show exactly how to use it. So is there any questions so far? Okay. You're not going to understand this next part, how to use this, but I'm going to show you how to export data. And this is the easiest way to create a data set. So you should have already installed the psych package and loaded it onto your library. I'm just going to run that again. So now I know psych is loaded. The describe by package basically runs summary statistics on a certain variable, and then it groups it by year in this case. So I specified the grouping variable as year. This mat equals true makes it so it will export it in a format that's useful. This syntax is not going to make sense to you. It shouldn't so far. We'll get more in the details of this later. I just want to create a data set that we can export down here so you can see what that looks like. So if I run the describe by, if you get an error on this saying that the function does not exist, that means you didn't install and load psych correctly. So we have our describe by. If we open this, we're going to see that for every year, it's giving us a mean, standard deviation, median, blah, 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 blah. So all of this would actually be covered in my statistics class if you don't know what this means. But it runs a bunch of summary statistics whatever you specify. In this case, the prescribing rate by year. I'm going to run the next thing. So this would be overdoses by year. If you open it, you're going to see that it did the same thing for overdoses. So now I have these as data frames. This is why I wanted to explain write.csv before. So I'm seeing in the chat here, please, if you have a question, unmute your microphone and ask it, because I can't check the chat throughout the presentation. So back to exporting data. So we created those summary statistics data sets. So this would be, for instance, an object in my global environment. Say, and the case that we're about to show is what's down here. This is the structure that I'm trying to specify up here for you. Down here is an actual real life example that we're about to use. So say and my computer is not plugged in, I apologize. So say we want to export the mean overdose by year. I'm going to show this in my code in just a little bit. This will be the object we want to export. It's here, it's going to be the write.csv function. So it's going to write a CSV file. And then the second thing that you specify in quote is the file name for this particular, the file name that will show up when you export it to the folder on your computer. So this mean underscore overdose by year, that's going to be the file name. And again, you have to specify the extension here. So you have to say CSV or you have to say .txt. You have to use this or you're not going to have a usable file on your computer. So you, again, can use a file path to specify where this goes, or this particular case, it would by default be going to my work directory that I already set at the top. So now, this will be exporting to my working directory. So we created these objects here. We're seeing them up here. So now I'm going to export this, export both of these. Now, if you come in, you're going to see sort by date modified. The mean overdose rate and the mean prescribing rate by year were just exported at 1156. So these were exported into my working directory, which is this folder, from my R code. So that is how you export files.